Hey guys, this video is going to go over what the immune picture that I did that Michael requested for us. So the lighting is bad here. I know you can see like the shadow of my phone, but so what I said was a pathogen. Let's say this is the coronavirus, will enter the body, right? The spiky things are the antigens. Remember all cells, allergens, foreign particles, not just cells, will have some sort of identifiable shape on the outside that the immune system can respond to. So one level of immune response, and this would be part of your innate immunity, by the way, this would not be adaptive, would be large phagocytes engulfing pathogens, right? So this would be, there's a phagocyte that's called a macrophage. It's a white blood cell, and it will do this process of engulfing, I don't know if it's one or a few, but a small number of pathogens like this. Sammy, this is only going to be a few minutes. And then after it does that, a macrophage is able to display the antigen shape, and that's how we get into adaptive immunity. Now that the pathogen shape is being displayed, the other white blood cells, particularly the T and B cells, can respond to it. So we'll have a T cell called a helper T here that will kind of approach this antigen display, probably bind to the cell like this and read the antigen shape. It will then, with that information, move over to where there are some plasma B cells. All these B, T, and phagocytes, they're all white blood cells, right? So let's not get that twisted, right? Now, you have probably 100 million different unique plasma B cells. The T cell will identify the one which will be, let's actually make one a different color, right? It'll identify the one cell that can make the antibody shape that's appropriate. The T cell will trigger this cell to proliferate, and it starts dividing and dividing and dividing and dividing and dividing. This takes time. This is why you're sick for a few days. When you get sick, I'm not talking about the coronavirus, but yes, the coronavirus, but just like a normal cold or whatever, you do have a period where you don't feel well as your immune system is kind of launching into gear. What are these plasma B cells doing? They are releasing antibodies, billions of them, right? And what are all those antibodies doing? They are attaching here at their binding site to a foreign particle, virus, or bacteria, right? And I'll make them trap sort of too. What this causes is a clumping up of the pathogen. The pathogen cannot reproduce. The pathogen cannot infect new cells. It cannot move freely through the bloodstream. And so this basically inactivates the pathogen, causes them to clump up. And at that point, I'll use my black marker here for the emphasis on death. At that point, cytotoxic T cells or killer T cells can come into these areas where there are large numbers of inactivated pathogens and release toxins that destroy them, right? And that would be the cytotoxic T. So if you think about this simple series of events, which I think is fairly easy to understand, that practice question we're reviewing today, it was asking you to name like different features of immunity. We have so many just right here. We have engulfing pathogens. We have outright destruction of pathogens, you could say. We have identification of antigen shape. We have proliferation of plasma B cells. We have production of antibodies. We have antibodies binding to antigens. We have all this stuff right here. That's like 6 or 7 things. And then the other thing that I don't want you to forget about is most of these, after the infection is over, most of these newly proliferated B cells will die and they'll just go away. They're no longer needed. But some of them remain boom, some of them remain as memory cells. And so if you're ever exposed again, you will respond with secondary immune response, which is faster. And that is the end.